So guys, welcome. I just wanted to share something that I built. So what did I build? Well, I built a freaking neural network in pure C++ from scratch. So here is the file. It's on my GitHub. You could check it. I will provide the link in the description. So here are the files. So here's the main, and this is a framework. So using these files you could build your own damn neural network. Let me just quickly demonstrate how it works. Okay, so well, we have many options. We can make custom neural networks, we can load neural networks, and we can interact with neural networks. I am also gonna provide a dataset visualizer things, so that's for a different thing. Let's just quickly tell you something. Okay, so we'll see so first let's start with Zor test. So for anyone who doesn't know Zor test is basically a neural network test or a test that is pretty elementary, and it is used to prove that the neural network that you built isn't linear. So what is actually Zor? If you remember from your college, Zor is basically a function that if the entries are 0 and 0, the output is 0. If the entry is 0 1, the output is 1. If the entry is 1 0, the output is 1, and if the entry is 1 1, the output is 0. So basically an exclusive OR. So a neural network cannot model this. Why? Because the Zor function starts at 0, increases to 1, and decreases again to 0. So if your neural network is linear, so is to say that it is having either a neuron or a chain of neurons that aren't interconnected in a map, they are just linearly connected, then what happens actually, your neural network will only learn things like y equals ax plus b. Your neural network will only learn linear things, but we don't want it to be linear, so we use multiple neurons interconnected and all those things. So that basically proves, the Zor test basically proves that the neural network that you built is working correctly and isn't linear. So let's just quickly make a Zor test, and let's clear the screen. Let's run. So as you could see, the epoch is basically the iteration. So I set it to run for 20,000 iterations, and the average cost. What is average cost? Cost is basically the sum of total error that your neural network currently has. So it starts at 0.3 and it goes to 4 into 10 raised to minus 5. So it's 5 decimal places after. So it's 5 digits after decimal, so it's really low. And as you could see, when the input was 0, 0, the prediction was 0.00, approximately 0. The target was 0, so it worked. For 0 1, the prediction is 0.99, so it's approximately 1. So you could see that this works. So now let's do the real thing, MNIST test. So for those of you who don't know what is MNIST test, let's quickly go MNIST test PM. So it's basically a handwritten digit test that identifying the digit that's written over the screen. So what did I do actually is I'm using a neural network, and I actually built an CMake command that actually just runs this thing. So not interactive, this thing. Okay, so as you could see here, or you cannot see here, let me just build and show you the thing. CMake, let's switch MNIST test on, and let's switch this off, and it built the test. Let's clear the thing. Let's start a neural network. So it allocates the memory first and then starts. So as you could see, it starts from 0.003. So why it does that is because of the fact that I already have a saved binary. This is the model representation binary. I'll be talking about that later. So my MNIST test is actually loading this. So let me just quickly define this thing. Let's go main, and where's the model? Okay, so here's the model. Let me just quickly remove this and go model.init. The living hell. Let's go with 128 by 10. Model.init parameter count, so it's just the image size that I have. Image size, and batch size is, well, batch size obviously. So we will be training a neural network from scratch. So let me move this thing here, and let's CMake the thing, and let's train the neural network from scratch. So it starts at 1.1, and it actually, as you could see, it is so fast. It's damn fast. Okay, so I am running this for approx 200 iterations, and each iteration trains the model over all of the 10,000 images. So the model is actually being trained over, I guess, 200,000 times, and it uses 200 megabytes of RAM, approx 200 megabytes of RAM. And as soon as this training is completed, it would save the model and it will infer the model. So it would test the model, how accurate is it. So let's just wait for this thing to complete. It's slow. I'm using only CPU, so it's still fast, because as you are seeing, the decrease, each decrease is 1,000 iterations going by. So each of this epoch cost is actually 1,000 iterations going by. Okay, so the memory usage was 191 MB approx, and it initiated the inferencing. The inferencing completed so fast that we were not able to actually see. The test accuracy came out to be 96%, so it performs quite well, and it actually saved the thing onto the MNIST test bin, and that's a thing. Now interactive, inside interactive, we are loading this thing. Let me just go MNIST test. So let's use this. Okay, so now we can actually infer this with interactive things. So I could go on, off, and let's go with this thing. So when I run this, it will open a window, and I could actually type anything, hit enter, and it will provide me the best prediction that it could give. So it is predicting 6, but this thing is actually 5, because I didn't made it quite the right way. So MNIST images are actually trained in a certain way. So if you do not provide the correct way of looking at things, it will just not work. So it predicted 7. So this thing is not actually working quite now, I guess, because the image has to be in a certain level. So it's I guess 20 by 20. You could ask ChatGPT or Gemini. It's actually 20 by 20, and the image should be centered about the center of mass that they call. So obviously it looks still now, and it looks still this thing, and it predicts it to be 2. But if I write the thing small, then it should work. So let me just try. Okay, so this is working, as you might see. Oh, it's not. Let me just try 4, I guess. Let's go with 4. 9 now. So yeah, there is errors in this thing because, well, okay, so this predicted 4 quite well. So I actually drew it correctly, that's the thing. So drawing it correctly and it will predict things correctly. So I need to work on that, but as much as the tests are concerned, this model is perfectly fine. It's 96% accurate. I just need to figure out a way to actually, draw the things correctly. Or in fact, I could actually try and do it right now. Instead of the image being 28 by 28, I'm gonna let the image be 28 by 28. And while drawing, if I get x being less than 4 and x being greater than 24, so that 23, 24, 25, 26, 27, 28, so it's like 20, 23, and if the same condition for y, so let me just copy paste this thing. So either this thing and this thing, or this thing and this thing. So either you have x less than 4, or so let's go with this, or this. So if this is the thing, then you are basically drawing in the wrong region, so you still have to draw it, but with some other colors. So let me go with something like red will work. So let's go red, and let's go see make the and let's run. Okay, so it actually provided the correct thing. So it again predicted 6, the living. Okay, let's quickly draw 8. No man, it is not 8. So yeah, it is not what I expected it to be. Okay, so finally it predicted 5 correctly. So it does the prediction, but you have to be really careful while drawing the thing. So that it predicted this to be 1, and it was actually 1. I could try something like 2. So it predicted 2. So yeah, it works, but you have to be really careful while doing things. Okay, so yeah, I guess this is it, and these all things are available on the GitHub, and like I said, that's it for today, and I'll be seeing you guys in the next video, and bye.